Welcome everyone to today's webinar. I'm excited to have you. We are going to be looking at the Tableau data model, which is a true game changer. It is a new feature in Tableau 2020.2. So I'm excited that you've joined us today. We'll get started with just a few introductory remarks. I am Joshua Milligan. There's some of my contact information. I'd be more than happy if you reached out to me. I'd love to interact with you and get to know you even more. I am a consultant at Teknion Data Solutions. So Teknion is happy to host these webinars, and I am grateful to Teknion for the opportunity to present to you. I love being a consultant at Teknion because my day-to-day job is working with clients using Tableau and Tableau Prep, and then working with other colleagues at Teknion to provide all kinds of solutions, everything from data modeling and ETL, so the data pipeline, analytics. We've got data scientists that I get to work with, true data scientists who understand all the regression models and predictive models that you could ever want to know. I dabble and pretend, but they actually know their stuff. So it's really great to work at Teknion. If you have any data needs, Teknion would love to talk to you and find out how we can help you meet those needs. I am a Tableau Zen master, so that is a selection process by Tableau. It is yearly. Every year they select a new group of Tableau Zen masters. Completely based on contributions to the community throughout the year, as well as technical expertise with Tableau. So it's a great honor, and I am very grateful to Tableau for that selection. I've actually been selected 5 times, which means that I was eligible and in fact was inducted into the Hall of Fame. And that also means I don't have to keep trying year after year to attain it. But still very much love interacting with the Tableau community. I'm also the author of Learning Tableau 2019 and am hard at work at 2020. So what you're going to see today about the data model is a lot of what I've learned as I'm writing the next edition of that book. Tableau 2020 is a game changer. And we're going to take a look at why that is. We're going to see how it shifts the paradigm. If you've ever used Tableau to connect to data, you're going to see some exciting things that make life a lot easier, but also require just a bit of understanding of some of the behaviors that you'll see. So we'll look at that and we'll talk about how Tableau data model works. A couple of things first. Yes, we are recording this, and it will be available. So there's the link, but don't feel like you have to capture it now. Everyone who registered should receive an email after the webinar letting you know when it's available there in the archive. Also, there's a Q&A box that is available with the Zoom meeting. Feel free as we go through this to enter in any questions you have along the way, and we'll try to reserve some time at the end to answer those questions and hopefully get most, if not all of them, answered or at least logged so that we can follow up afterwards. Let's start by looking at just some sample data. This data is similar to some data that you may have worked with in your organization. This is actually more based on maybe a personal budget, but the idea is that I have a daily list of expenses. So these expenses happen throughout the day. Every row is a single expense, and you can see that it's got an amount associated with that as well. So every day I'm spending money, but I do at a monthly level keep track of a budget. So month by month, then I've set aside a certain amount that I don't want to exceed for the month. And this kind of data structure is very common throughout most organizations, whether it's financially looking at budgets and expenses, or looking at revenue versus goals. It's very common to have things that happen at a daily level, but you compare it to a monthly goal or a monthly threshold, or even something that maybe happens at a monthly level, but you're comparing it to a yearly threshold. And so how do you deal with this in Tableau? How do you build out a data structure that works well? Well, if you're using 2020.1 or earlier, then there are several ways you might approach it. But let's take a look at some of the challenges you might face. So I'm going to bring that data set in to Tableau. This is Tableau 2020.1, so we're not looking at data model yet. But you can see I've got here in my spreadsheet, I've got my daily expenses. And just as we saw before, an expense, every expense that happens on a given date, and then a monthly budget. So previously, I might think of joining these together, or maybe using a data blend would be another approach. But either of those approaches comes with some potential challenges. First of all, I have to decide how do I join these together? I actually have a month field at the daily level, so it's just rolled up to month. That makes the join on the value easy. But then, what type of join do I use? Do I use an inner join? Well, that could be problematic because an inner join means that I'm only going to match the records that find a match. But there could be cases where I have expenses that have not been budgeted yet, or I may have budget lines that don't have any expenses yet. So if I do an inner join, I'm going to lose some of those. I could do a left join and say I want all my expenses, whether they've been budgeted or not, or I want all of my budget lines, whether they've been budgeted or not. Or I could do a full outer join and potentially get both. But then, even then, as I start to apply filters and that sort of thing, I'm going to come up with potential problems. I'll simplify it right now and just say let's do a left join. So every expense, even if it's not budgeted for the month, we'll take those. And if there's a budget line that doesn't have any expense, I guess we'll lose that from today's analysis, but maybe not a big deal for what we're doing right now. So a left join, and then I come into a new view, and I get ready to start to look at that. And I think I want to look at how much I've spent, so the amount over time. So I'll look at it. Well, I'll expand it down to the month level and take quarter out. So I have my daily expenses. Tableau has nicely rolled them up to the month level, and I can see, how much I spent each month. No big deal there. But now I want to bring in the budget and see how did that compare with what I budgeted. So I think, well, let's just place that on rows and get another line, and look what happens. Tableau says I've budgeted $36,000 in January, or even $78,000 in May. Now, on the one hand, that's great because I came in way under budget. On the other hand, it's totally wrong. That's not at all what I budgeted. In fact, if I were to remind myself what the data looked like, you can see it was $3,000 or $5,000. So what's going on here? Why am I getting these values? Well, that's because the join is taking every expense and matching it up with the budget. And so what I'm getting is I'm getting duplicated budget values. If I look at the data here, I view the data, I can see that that every expense includes the budget for the month. So 3,000 because that expense happened in January, another 3,000, another 3,000. And so all of those then add up and become 36,000 dollars, and that's not at all what I want to do. So I have to address this in some way in Tableau. At the month level, I could potentially just change the aggregation here. I could say, well, let's look at that as a minimum or a maximum. That actually works. That works really well, but doesn't necessarily work at every level. So if I back it off to the year, I've spent $25,000 total, but I've only budgeted $3,000. No, that's just the minimum budget for the entire year, but 3,000 may be the smallest budget for a given month, but it's not the sum of all the months. So that doesn't always work. I'll undo that and go back to the month level. What you've probably done in the past is to use level of detail calculations. So I can create a calculated field. We might call this our budget for the month. And we'll do something like a fixed level of detail at the month level. And I nicely have a month field there. And then I could do something like min or max or average of the budget number. Now what this does is this says for every month, let's just capture that minimum budget level, but it will work at any level of detail, which is nice because now if I take this budget for the month and replace budget there, you can see I'm getting the right values per month. But if I go to the year level, now I see my total budget for the year is 26,000. My total expense is 25,000. So I've done okay. That looks pretty good, and it's working. It's right. It should work at any level of detail. There might be some potential issues. For example, if I said let's filter out some of my expenses. So let's get rid of house or clothes, and I exclude those and apply that. You can see my my total amount that I've spent has changed. My total budget has not necessarily changed. And there are multiple reasons for that in this data set, but one thing to always be aware of is that a level of detail calculation, specifically a fixed level of detail calculation, doesn't change based on normal filters. It is calculating it for the entire data set, so no matter what I do, I'm still going to get that value. In fact, I can illustrate that even more by taking the month itself and creating a filter on that. So let's filter out based on months, and let's only look at January and February. I say okay. Now this time it actually did work because it excluded everything, but sometimes it would not work. So there are complications to using level of detail calculations, and it will work, and it has worked up until 2020.2. In fact, it still would work, but now there's an easier way. So I'm going to close out of this and bring up Tableau 2020.2. Here's our data model version, and I'm going to bring that same data set into Tableau now, budget and expenses. You'll notice a little bit of difference here on the data source screen. There is an area that says drag tables here, which is great. I'm going to do the same sort of thing where I drag in my daily expenses. And it looks the same so far, or at least very similar. I've got a daily expenses table. I've got, this is a little bit new. It says need more data. Drag tables in here to relate them. Now, before I would drag them in to join them, we're going to see that this is a little bit different. This is a relationship and not a join. So now I'll bring in my monthly budget. And look at that funny little connecting line. The Tableau developers call it a noodle, which kind of is. I guess it's flexible, kind of like a noodle. and it's kind of fun to play with. And then when I let go, it drops in that table and says, what is the relationship? And you can see it picked up that the relationship was month. That field appears in both data sets and is the same type. It's a date. If I had other tables with ID fields or potentially some other kind of an identifier, it would pick that up as well. And if I was using a relational database with those relationships already built in, Tableau would potentially pick those up instead of just making its best guess. So I can add more fields to further say that what needs to match in the relationship. I've got some performance options. We'll talk about that later. But for now, I'm just going to accept the fact that the relationship is at a month level. That's what I want. And I'm going to close this out. And now let's go back to Tableau and take a look at how this works. One thing you'll notice right away is the difference over here in the data pane. So where you have your list of fields, it used to show a list of dimensions at the top and a list of measures at the bottom. Now what you'll see is a list of fields by table, and they are broken up into measures and dimensions. So you'll see this little line here in between. That says the top part here are the dimensions for the table. The bottom part are the measures. At least it's best guess. Now a row number is not a measure, so I can drag that up and redefine it as a dimension. And as I drag it, it even gives me some helpful highlighting there on the line to tell me the dimensions are above, the measures are below. And so I drag and drop, and I can recategorize things. Most of the time, you'll notice dimensions are this blue color, but that blue doesn't necessarily mean dimension. It means discrete. And green does not necessarily mean measure. It means continuous. And in fact, I can change continuous to discrete. I can change row here to continuous, even though it's dimension. Now you'll see it shows up green. So the color coding might look one way at first, but that's not necessarily the indication. The indication is the line that appears. And you'll see monthly budget is the same way. I've got my list of measures here, my dimensions here, my measures here. And you'll notice one other difference from what you may be used to in Tableau. Before, I had a number of records field, and it would show up at the very bottom of the measures list. Now what I get is I get a count per table, because as we'll see with relationships, what the relationship does is it will actually count or do any aggregation at that table level. So I actually have a different number of budget records than I do daily expense records. And that is the secret sauce, as it were, to the data model, is the fact that it's going to do these aggregations at the correct level of detail. And so let's take a look at how that works. I'll do the same sort of thing. I'll take my amount and drop that in. I'll take my date and build out the view. Before we looked at it by month and without quarter, so that looks great. And same sort of thing, I'm getting the right values here. But previously, when I brought in the budget, it was duplicating it for every expense. Let's take a look now. Now, it gives me the correct value of budget. Why? Because it's doing the aggregation, the sum of budget, at the monthly budget level. So it's only adding 3,000 once for January. It's only adding 4,000 once for February. And that's wonderful, because I didn't have to create a level of detail calculation. I didn't have to think through all of the complexity. All I had to do is create that relationship initially, and Tableau says it works great. But does it still work if I go back to the year level? And the answer is yes, it still does. So Tableau knows no matter what level of detail my view is, always aggregate budget based on the level of detail of that monthly budget table. And so that works out really well. And always aggregate amount according to the daily expense table. And it works so well. I can do all kinds of aggregations here. I can say, what's my minimum budget for the year? 3,000. Well, that worked before, and maximum would work, but average would have never worked very well. But I can get that to work very well now. With the join, it would have been more of a weighted average, depending on how many expenses I had each month. But now I'm going to get the correct value there. So data model makes it very easy to work with different tables and relate them together and come up with correct analysis the first time without having to create a bunch of level of detail calculations or doing blending, which can work well, but can also introduce some complications as well. So that's a simple example. And you say, well, the simple example works well. What happens if we get a little bit more complex? Well, let's think about that. So here's another data set that we'll take a look at. This data set starts with a table called hospital visit. And what we'll see is that there is a record per visit to the hospital. So a patient comes in, checks into the hospital, they have some sort of a diagnosis that's made, they're admitted at a certain on a certain date, and you know, there's some other admission types and what location of in the hospital did they check into, how long did it take to get them checked in, how many minutes did it take. So just a pretty standard table, and it's just one record per visit. You'll notice here that that this could be a relational database because it's set up really nicely with some relational keys, a primary key here, a visit ID, and then some foreign keys that that tell us that there's some data in other tables. Now, in fact, this is just a representation. We're going to take a look at this data in Excel, so these relationships are not built in, but conceptually, that's kind of what we have. So the visit ID is the primary key. We've got a couple of foreign keys. Minutes to service is a measure, and the other fields are all going to be dimensions to tell us attributes about the visit. Patient ID then points to another table called patient, which we would kind of expect. But this table consists of all kinds of patients. We get their name, their birth date, male or female, and age at the most recent admit. So how old were they when they were admitted to the hospital? Something we could probably calculate from the birth date, but that's kind of nice just to have it there. Again, that's going to be our measure. Everything else will be attributes in that table. One thing you can't tell from the diagram, but I happen to know about this data set, there are additional patients in the data who did not show up in the hospital visit table. So I think we've got in this sample data set, we've got 10 patients in the patient table, but only 6 of them actually had visits. And why, I don't know. It could be that, you know, some of the patients are coming from a legacy system that didn't record the visits. Maybe they're historical records that we didn't track the visits, or who knows why. Maybe they have some sort of a relationship with the hospital other than having actually visited. But there are additional patients in that table. So just remember that as we think about this data set. Discharge details is another table that that just contains information about the discharge from the hospital. So when did they leave? The disposition tells us where they went. Did they go home? Did they go to another facility? And then apparently this hospital did a survey. How did patients feel about their care? And it's a value of 1 to 10. So that'll be our measure on this table. Now, interesting to note that we've got the opposite issue with discharge details that we did with patient. Patient had extra patients, Discharge details, turns out not all patients have been discharged yet, so some of them do not have a record in the discharge details table. Now, in a true relational database, they probably would, and it probably would just say something like, this patient hasn't been discharged yet. But here, turns out discharge details ID in the hospital visit table will be null, indicating they're still in the hospital. There's no discharge record. So with that kind of an overview in mind, let's take a look at how this would work in data model. First, let's just real quick look at the data that exists here. We've got the hospital visit table. You can see 10 visits, but as I mentioned, some of the patients actually have returned to the hospital. So we only have 6 unique patients who have come into the hospital. And also, as I mentioned, the discharge details is blank for patients that are still in the hospital. And then we've got our patients. Now, I said it was one table. Turns out it's actually 2. There's a list A and a list B. So 2 different lists of patients, 10 patients total, but only 5 in each list. Maybe one's our legacy system and one's our current system. That could be part of the issue, or who knows. But that happens sometimes with data. You'll notice the ones that haven't visited the hospital, they don't have an age at most recent admit. That's fine. Discharge details, so very simple data set here. No major things to note here, other than there are not going to be records for patients that have not been discharged yet. So if we take this data set and we take it into Tableau data model, what will we be looking at? I'm just going to drag and drop the Excel file onto Tableau, and that brings up the data source screen, and we get the hospital visits. Now, interestingly, with the old version of Tableau, or a previous version of Tableau, it actually would make a huge difference which table I started with, because I would want to start with my primary table, hospital visit, and then everything that joined onto that I would bring in next. With the data model and building out relationships, it doesn't matter as much. I can start with any table and say that there are relationships, but I think it's probably still good practice to think through in your mind what's the primary table and build it out that way. So that's what I'm going to do. I'm going to start with that hospital visit table, and I'm going to start to build out. Oh, you know what? This is the old version. That's not going to work. Let's come back. Here's my data model version. Let's try again. So here, yeah, so now I see the drag tables here. Here I'll start with hospital visit. Pull that out, and I get hospital visit here. And I want to start to relate these together. Discharge details. I'll bring that in, and it notes that the discharge details ID is the field that it thinks matches. That's correct. I'll accept that. And then patient list. Now here I'm going to have an interesting thing to think about, and that is the fact that I've got patients broken out into 2 different lists. So I'll take patient list A, drag and drop that one. Patient ID is what I build the relationship on. And then patient list B, I could potentially build out a new relationship, but that's not at all what I want. In fact, what I want is to union these together. And that's very easy to do, but it also brings up a point of discussion, and that is the fact that data model consists of 2 different layers of the data model. One is what we're looking at here, and this is called the logical layer. Everything here is just a logical table. So hospital visit is a table of data that relates to discharge details, that relates to patient, And in the logical layer, this is just one table. But if I were to drill into that, if I were to open it from the drop down here or by double clicking, then notice that it's really made up of two tables. This is the physical layer. So I can have a physical layer made up of all kinds of tables. They can be unioned together. I can use the old style of joining tables together, and ultimately the flat data set that I get here in the preview becomes the single logical table. So I'll close out the physical view. It becomes the single logical table patient. And in fact, I'm going to rename that because we have both lists in there now. And so that's a major change, is that I'm thinking here at a semantic layer that's logical tables, but they could be made up of more than one physical table. So here I've double clicked, I've gone into the physical layer. It says the physical layer for a hospital visit is just one table. And in fact, it tells me that, one physical table. But I could join this together with other things and union it. And no matter how much complexity I built out here, when I close it up, it's just going to be one flat logical table that relates to other flat logical tables. And that gives me a lot of flexibility to build out complex data structures and then relate them with other complex data structures, but to relate them in a very simple way. So potentially just a single field that tells it how it relates. Let's take a look at how this works then in Tableau. So I'm going to come back to Tableau here, and I'm going to say we've got our hospital visits. Notice again, it shows me each logical table and all of the fields that belong to that logical table, again, broken down by dimensions and measures. Although, again, you may find some ID fields probably should be dimensions and not considered measures. But now what we're going to find is we're going to find some very interesting behaviors of data model. And it may take just a little bit of getting used to and thinking through, but once you have these behaviors down, once you've worked with it just a little bit, it's going to feel natural, and all of a sudden, you're going to have all kinds of flexibility that you never had before. So for example, you'll recall that I said, there are 10 patients in the patient table, and but not all of them had hospital visits. So just think to yourself, if I drag name out here and we look at the names of these patients, how many do you expect to see? 10 or 6 that had visits? I'm going to do it here in just a second, so think about it. Turns out I see all 10 patients. And this is wonderful because I didn't have to think about what kind of join I wanted. Did I want a left join, right join, inner join, outer join? Tableau takes care of that behind the scenes. It figures out what tables it even needs to query, and then if it has to query more than one, what kind of join should it use? So I can look at all of my patients who have ever had some sort of a relationship with a hospital, and then I can start to do other analysis and say, well, what if what if I wanted to also know what their primary diagnosis was? So I could bring that in. Notice what happened to my list here, and all of a sudden you might think, whoa, what happened? Because now I'm only looking at 1, 2, 3, 4, 5, 6 patients. Those are the 6 patients that exists in both tables. And so I had 10 patients, but only 6 of them have ever had a visit with a diagnosis of some kind. And so Tableau said, okay, since you're looking at dimensions from 2 different tables, I'm only going to show you the ones that matched between those tables. And then you'll think, but there are times I want to see all the patients, even if they didn't have a diagnosis. So how can I do that? Well, watch what happens if I take something like the number of visits from the hospital. So I'm going to drag and drop that over here. No change because these are only the patients that had a primary diagnosis, and so I'm seeing the count of visits for each patient for each diagnosis. So Hillary's come in with congestive heart failure twice, and then again for pneumonia. Everybody else has only had one visit per diagnosis, although a couple of them have had a couple of visits with different diagnoses. So that's interesting. But watch what happens if I were to take a measure from the patient table. So the patient count, we'll start with that. Now notice that I'm back to seeing all 10 patients, even if they didn't have a diagnosis. And that's because I used a measure from the patient table. So Tableau says, oh, okay, you wanted to know how many patients there were, and it's going to count them. Notice that the primary diagnosis is null. And if I bring back in my hospital visit count, now Tableau very nicely gives me some decimal points, which is interesting. But you'll see that what Tableau is saying is that there are some who have had 0 visits, but they're still counted once as a patient. And that's exactly what I would expect to see. So having the measure from the patient table tells Tableau, show me that patient. Having the measure or the count from the visit table says, show me the number of visits, and in fact, some of them are going to be 0. Now, what about this minutes to service measure? What if I look at this one? Let's not do a sum. Let's drag it out here with the right mouse button and select average minutes to service. Notice that Tableau does not use 0 for patients who have not had a visit to the hospital. Count is the only one that will show up as 0 because it truly is a 0 count. But every other measure, such as minutes to service, that is not an applicable measure. It shouldn't be included in averages. It shouldn't be included in minimums or maximums, right? Because my minimum minutes to service is not 0. So if it had told me that Daryl had 0 minutes to service, that's not the minimum that I've ever gotten a patient in. My minimum is truly 6. So Tableau is being very intelligent about how it treats the measures from different tables and how that should work. And what you'll find is that as you work with data model, you'll find that everything works as it should, but you do have to get a little bit used to some of the behaviors itself. So here's the way that I think through those behaviors, and the way that I've started to sort of remind myself what to expect with those behaviors. I've got sort of four different rules. One is that if I take a dimension from a single table, so one dimension from one table, I'm going to see the full domain. That is, I'm going to see all the possible values from that table only. So I'm going to see all 10 patients, regardless of whether they match with anything else in any of the other tables. I'm going to see all of them. If I use a measure from this table, then I'm still going to see all of them. So that doesn't matter. But if I then use a dimension from another table, so primary diagnosis. So now 2 dimensions from 2 different tables. Now the default is I'm only going to see the matching values. So Tableau is doing, you might think of it as an inner join at the data model level. So Tableau is deciding only showing me the matches. But if I want to go back to seeing that full domain, then go back to that original table and take one of the measures there, Now I'll get that full domain back, and I'll get nulls for the other dimension. So I've got a lot of control over how I see things, and now even if I bring in other measures, I will not see them for those patients, but they're still showing up. And so then if I want to, if I did actually want to see their age and I wanted to see their minutes to service, if I want to see both of those, but I only want to see the ones that that did have a diagnosis, then I've got a lot of flexibility there too, because I can say, you know what, I can use a measure here and force it to be that inner join kind of experience where I say, let's look at patients who have visited the hospital at least one time. And now I'm back to seeing only patients who visited the hospital. So a lot of flexibility in terms of how I do the analysis, a lot of potential, and reduced complexity. I'm not creating level of detail calculations to solve these problems. I only just have to be aware of some of the behaviors of the data model, and at that point, I can get it to do whatever I want. One last thing that I'll point out, you see this age at the most recent admit. Well, each admission has a value, so I'm actually seeing that value repeated in the table. Does Tableau data model, does it potentially add these together if I were to look at subtotals? Take your best guess before I do it, and as I do it, no, it does not. So Tableau knows the age at the most recent admit, that's calculated at the patient level. So even if I'm totaling it up for that patient, I don't duplicate it. However, minutes to service is calculated at the hospital visit level. So each visit adds to that. So Karina has had to wait 87 minutes total for all of her visits to the hospital. Sorry, Karina, that's a long time, and we'll try to get that better. Tori has done really well, 6 minutes, that's great. All right, so that's sort of an introduction to data model. It's a huge change to Tableau, but hopefully a fairly intuitive change once you get used to it. I see quite a few questions, and I'll try to answer those as you think of more. So feel free to continue to add in questions, but let's start here with the first question. Is data model structure the only option in 2020.2, or will there be a legacy view with the typical joins? So that's a great question. What you'll find if you were to look at something that's a legacy connection is when you open it in Tableau 2020.2. So let's say, for example, I'm going to find a legacy version of something to open. All right, so here is a legacy workbook. I'm not sure which version it is, but it should tell us as it opens it. And of course, I picked one that takes forever to open. Let's try a different one. Okay, here comes something. I don't even know what this is. Oh, seriously. All right, so here it is. It has opened up this previous version, and what you'll see is that everything in 2020.2 uses data model. But if it comes in from a previous version, you'll simply have one logical table called migrated data. And then when you open that up, then that will show you all of your previous joins and everything. So even if you had other data that had been joined together, oh, it doesn't like that one for some reason. Yeah, so there you go. So even if you had built out a large connection made of many tables joined in union together, all of that will be contained in a single logical table when you first open Tableau. And you can see here, it's giving me an icon. Previously, we saw an icon that showed that it was a union at the physical level. Here, it's showing me that I've got some tables joined together, and hovering over tells me how many tables. So two tables joined together. So it will work seamlessly. You won't notice any issues with that, because at the physical level, it's doing everything exactly the same as it did in previous versions. The only thing you'll notice differently is how it presents that, and the additional options that you then have to relate other data to that physical model that you've already previously built. And if you want to join tables together like you did previously, it's the same basic thing, except that you'll create one logical table made up of as many physical tables as you want to relate together. So the answer is yes and no. Yes, everything in 2020.2 is a new data model paradigm, but no, you don't have to worry about the fact that that's going to change anything at what you did previously. It will all still be there in one logical table. All right, so there's another question here. How would it perform if have I tested it with multiple dimensions, about 8 to 10 dimensions, a fact table, and about 3 million rows worth of transactions? Can we work with data model using extracts, publish it like a data source? And what about live connections? Okay, lots of intricacies on that, but it does bring up a lot of interesting points. Performance is an interesting thing to consider, because when you look at the potential performance, it will just as it always has, it will depend a lot on the underlying data source, the complexity, the number of dimensions, how wide the table is, all of that sort of thing. But we do have some capabilities with data model to make it more performant. One thing that I have noticed is that building out these relationships, Tableau is very smart about which table it queries, and if it needs more than one table, then it can build out some optimized queries to get data from both. I'm sure there's a little bit of overhead, but I have not noticed any significant changes. And you shouldn't notice any changes with your old workbooks that are using the single logical table. That shouldn't impact performance at all. If you do have performance issues, or you just want to streamline it for performance, I had mentioned there are these performance options. So for each relationship, I have the ability to look at these performance options, and it's got two different concepts here: cardinality and referential integrity. Uh, if you have those constraints built into your database already, and Tableau is able to query the database and find those, it will set those as the defaults. If it's something like Excel, or there aren't any constraints or relationships defined in your relational database, then the default is this. Cardinality, meaning how many records match from one side to the other, so from hospital visit to discharge details. Can each hospital visit have many discharges? Can one discharge apply to many visits? Well, no, it's a one-to-one relationship. Each visit has one discharge. So I could actually set that here. I could say this is a one-to-one relationship, and that will help Tableau as it builds out queries know exactly how to build those queries out in the most performant way. Same thing with the referential integrity. So you'll recall that I said not every visit has a discharge, but every discharge does apply to a visit. So I could say, you know what, all discharges will match a visit, but only some visits will match a discharge. So setting these options will potentially help performance. I mean, with this data set and 10 records, no, you're not going to notice any difference. But 10 million records, yes, you might start to notice a difference there. The only caution is that if you get it wrong, then some of your analysis could be wrong, because this is also how Tableau is deciding how to aggregate things and how to show you the full domains or partial domains of dimensions. So only do this if you actually know the relationships in your data. But if you do, this is definitely a possibility for improving performance. All right. Oh, one question here. Can I show the patient list in Excel because were there 10 or 6? So there were, in fact, 10 patients split up over 2 lists. So you can see here my patient ID starts with 101, goes to 110, but that's split up over these 2 lists. So 5 patients here in list A, 5 other patients in list B, and all unique patients. So that's how that was kind of split out. Kind of a horrible way. I wouldn't ever intentionally do this in Excel, but you definitely will find data sources where your full list is potentially in multiple systems or something similar to that. All right. Yeah, so Anonymous says, this truly is a game changer. Thank you so much. And when is this version available? It is available now. So Tableau 2020.2 is the most recent version. Does it work with Tableau Online, extracts and extracts in general? So yes, when I go to extract the data, notice my options here when I extract, and if I were to do it or edit, I'm going to get some options here. One is to extract the logical tables. So each one of these is going to be a separate table in the extract. Or if I had multiple physical tables, here I kind of do, but it's just a union. But if I had joined a bunch together, I would have an option for extracting each physical table. And that's going to be the new set of options in the extract. But otherwise it works exactly the same as you're used to with extracts. Extract filters work fine. It's just a matter of how do I want it to store the extract. Logical tables is going to be the default, but there are times, even now, in previous versions, where you would tell it create one giant extract, which would be one logical table, or extract each table individually that are joined together. And so that would be your options now. Now you've got this new set of options, but it's kind of the same basic concept. Any issues with published data sources? No, I wouldn't expect any. And is custom SQL still an option? Yes. So custom SQL, stored procedures, all of that is still going to be an option. A stored procedure is going to come in as a single logical table with no ability to join it to something else. You can relate it to other logical tables, but if this was a stored procedure, I couldn't drag in other tables or stored procedures to join to it at the physical level. But custom SQL, absolutely. So if this was something other than Excel, if this was SQL Server, Oracle, or Snowflake, or something like that, I could drag that custom SQL up here, write out my custom SQL, and that becomes a physical table that I could join or union or however I wanted in the physical layer. And then when I come back to the logical layer, that could have the custom SQL as one or more tables represented within it. So absolutely, that would work. All right, let's see here. Awesome overview. Thanks so much. Thank you. I appreciate that. When you have 20 plus SQL tables, would you use custom SQL to join or use the new data model? Ooh, that's a good question. That would totally depend on how you might relate them together. And yeah, I mean, boy, that would be a tough thing to just answer generically. What I would say is that I would use data model in almost every case where the tables, even if they are at the same level of detail, so hospital visit and discharge, really that's the same level of detail, just some don't have discharge. That's fine, especially where I'm bringing in dimensions, maybe to a fact table. It works really well. The only case where I might say, well, not the only case, but one case where I would say let's join them together is where I specifically want to control the join. So I say it has to be a left join every single time for the analysis to be correct, or it has to be an inner join, because if it doesn't find a match, I don't care to know anything about the ones that don't match. So if I want to control the join, that's where I'll go into the physical layer and create the joins very specifically. But if I say, you know what, I want the flexibility in my analysis to look at all patients, even if they don't have a visit, or in some cases, I will limit it to only patients who had a visit, but I want that flexibility, then data model is definitely the way to go. One final question here. From a corporate perspective, do you feel some level of retraining will need to be offered inside companies to help Tableau developers? Any recommendation or any recommended format for this? You know, it definitely is a major step forward, and anyone who is building out connections for your organization, they should definitely spend some time understanding data model. It could be that would be some retraining or some additional training. You know, at Teknion, we are constantly building out training modules, and this is going to be one of them, is data model. So that would be something we'd be happy to help you think through. But additionally, you can read the Tableau documentation. They've got a good set of blog posts and help documents, and even some videos that they're coming out with now. So in many cases, that will be enough for most people. But definitely, if there are people who are thinking through the intricacies of how do I create governed data sources for the entire organization at that kind of level, it definitely would be helpful to get some training and to think through all of the different aspects of what data model changes, and then to roll that out across the organization and say, you know what, if you're consuming some of these models, be aware of the behaviors of data model, be aware that you can now see all your patients, or you can limit it to the ones who've had visits, or you can see all of the customers or only the ones who've, you know, made purchases, or, you know, whatever it looks like in your organization. But yeah, that would be very helpful. All right, thank you so much for joining this this webinar. We're at time, and so I'm going to close this up. Feel free definitely to reach out at any time. Let us know what you like in webinars, what you don't like, what we could do better, and also if there's any way that we can help you as you think through your data strategy, as you think through how data model is going to impact your organization. Feel free to contact us and let us know that as well. Thank you again. I'll see you next time.